Welcome to Unit Circle Survival Guide. Today we're going to talk about some special angles on the unit circle and how to label them in degrees. So here's a classic unit circle. Before we jump into labeling, let's talk some terminology. So remember, an angle is simply two rays connected by a common endpoint. And when we're on the unit circle, our standard position is going to be having the initial side on the positive part of the x-axis. So here's the origin, that's where the point is, and that ray is our initial side. And so we will measure the amount of rotation from the initial side to a terminal side. So let's say that's this ray right here. So we're simply measuring this rotation. And when we label all these angles, that's what we're doing. We're saying, okay, from the initial side, how much rotation do we have? Okay, so let's start labeling. We know, of course, if we don't rotate at all, we've gone 0 degrees of rotation. And if we rotate a full rotation, a complete circle, we know that's 360 degrees. So when I label, I don't necessarily go completely in order, just rotating counterclockwise around the circle. I like to break the 360 degrees down. And this will also be helpful as you look later to finding exact values from the unit circle and knowing the reference angles. And so that's sort of how I have this set up. So first I think of half of 360. So that's a half rotation, or 180 degrees. And then I break that down again. So half of 180, or a quarter rotation, would be 90 degrees. Okay, so each quarter of the circle is a 90-degree rotation. So we have 0, 90, 180, and then 180 plus 90 gives us 270 here. So we have all of these quadrantals labeled, and those are the angles that land on axes with their terminal side. All right, so then I like to break down into the other multiples of 45. And so these all have that same reference angle of 45 degrees. And remember, a reference angle is just the amount of rotation to get back to the x-axis. So we're looking at these terminal sides in particular. Okay, so of course, if we do half of a rotation between 0 and 90, that's 45. So these are all in increments of 45, like we've said. So we've counted 0, 45, 90. 90 plus 45 is 135 degrees. And then, of course, 180. 180 plus 45 degrees is 225. We've got 270 labeled. And then 270 plus 45 is 315. The last thing I do is to label counting by 30 degrees. Our first angle here is 30, and so we'll count, and this will hit all of the ones that we have not labeled. We've basically divided that first quadrant into thirds, or 30-degree increments of rotation. And we don't have to worry about the ones highlighted in yellow because we've already labeled those. Those were in increments of 45. So we're counting 30, 60, 90 is already labeled. The 90 plus 30, 120, plus another 30, 150. We've got 180 labeled, plus another 30, 210, 240, 270 is labeled, 300, and 330. And you've got your unit circle labeled in degrees. One other quick note, let's look at the reference angles that are similar. So these that we just finished labeling are all from 30, 60, 90 special right triangles. We'll talk about that in a later video. But notice that how the triangles are oriented when we will draw them is different. So you will drop down that right angle, and we're looking at a triangle here versus a 60-degree triangle, which would be here. So you can see that they're just flipped and rotated. But notice that these angles highlighted in green have similar reference angles, or the same reference angle. Remember, amount of rotation to get back to the x-axis, so 30 degrees. Whereas these angles, highlighted in blue, have 60 degrees of rotation to get back to the x-axis, so that's their reference angle. Hopefully this helped you feel really confident labeling your unit circle using degrees. Check the video description, there will be links for labeling using radians. There will be links to help with special right triangles and labeling the coordinates of the unit circle, and just some other good trig goodies and how to survive the unit circle.